Hi, I'm David Peacock, and this is Exponential and Logarithmic Graphs. There's not really one parent function of an exponential function. It depends on what the base is. There are, however, two main types of graphs. We have exponential growth functions, which look like this. And if you look, there's no reason why there couldn't be. They seem to be going out in both directions forever in the domain, so our domain is negative infinity to infinity. But you might notice it seems like it's kind of turning right at 0, and that's because the generic form of the range will be 0 to infinity. Now let's talk about exponential decay. It's going to look almost exactly like growth, just like it's a mirror image, a reflection on the y-axis. So our domain, our x values, those are still going to be pretty much just like opposites, but because it was negative infinity to infinity, those just switch, so that infinity becomes negative infinity, the negative becomes positive, so it still says negative infinity to infinity. And our range, it didn't move up or down at all, so it's still going to be 0 to infinity, just approaching 0 on the right instead of on the left. So let's try this out. What we're going to do now is y equals 2 to the x. So I'm going to find some points and we're going to plug those in. I'll start at 0 because 2 to the 0 is 1. Now if I do 2 to the first power, that's going to be 2. 2 squared is going to be 4. Now if I go negative 1, remember it's 1 over 2 to the first power, so 1 over 2. And negative 2 would be 1 over 2 squared, so 1 over 4. Now that we have all those points, here we go. And our domain and range are obviously the parent versions. We've done nothing to move it up or down or left or right. So domain is negative infinity to infinity. Range is 0 to infinity. But our asymptote is going to be the line that it seems to be stopping at. And like I mentioned earlier, it appears that it's getting close to, but it never quite touches y equals 0. All right, now let's talk about this next one. It says 1/2 of x. Now x and y, we're going to start at 0 again because anything raised to the 0 power is 1. If you go to the first power, it's just the number we had, so it's 1/2, and squared, half of half is, well, a fourth. Now let's talk about the other side. If I go to the negative power, it's actually going to become its reciprocal. Negative 1 makes it the reciprocal of 1/2, or actually just 2. And I'm noticing something. When it was 1 on the last question, we said 2, and when it was negative 1, we said 1/2. I'm thinking that these are just reflections on the y-axis. So let's see. If I do negative 2, it's the reciprocal of 1/2 squared, which, yeah, would make it 4. So this is just a reflection. This graph should look pretty much the same, just going the other direction. Meaning our domain isn't going to change. Our range is still 0, and because our range is 0, our asymptote is also y equals 0. Now let's try this one. If you look, it's y equals 2 to the x minus 3. Now you might remember this is what y equals 2 to the x looked like. But because it says minus 3, that means that just each y value goes down 3. So like for instance, 0, 1 is now going to be 0, negative 2. And it just approaches now 3 points lower. So what you would do is, if you're looking on the notes that I've given all of my students, you would take the y values on the one right above it, y equals 2 to the x, and just every y value subtract 3. Our domain would stay the same because left to right it's no different, but now our range, it's no longer 0 to infinity, it's now negative 3 to infinity, which means our asymptote is y equals negative 3. Now let's try this one, 1/2 x minus 2. So you might remember this is what y to the 1/2 x, y equals 1/2 of x looked like. Now, in this case, notice that the minus 2 is in the exponent with the x. that means it's going to move either left or right. And because it says minus 2, it actually moves right 2. So if you are looking, once again in your notes, instead of taking all your y values and subtracting 2, you would actually take all your x values and instead of subtracting, add 2, meaning 0, 1 becomes 2, 1, and so on. But that said, our domain, because it's negative infinity to infinity, wouldn't change. Because if I have infinite dollars and I have to pay 3, I still have infinite dollars. But our range, because we didn't move up or down, actually stays 0 to infinity, which means so does our asymptote, y equals 0. All right, now let's try this one. You'll notice this says 2 times 3 to the x plus 1. Now, that plus 1 is going to mean everything moves up 1. But it's not going to move left or right, so I would actually just plug in values personally. I know what this means, the plus 1, the times 2. But I'm going to start at 0. So when x is 0, 3 to the 0 is 1. But 1 times 2 is 2. And then we have to add 1, meaning when x is 0, it's actually 3. If I say 2 times 3 to the first, that becomes 2 times 3 is 6, plus 1 is 7. So at 1, it's 7. I've already gone above my graph. So now I'm just going to go to negatives. 3 to the negative 1 is 1/3, times 2 is, that's 2/3, plus 1 is 1 2/3. And then negative 2 is 1 2/9. And there's our graph. Now, the fact that it's times 2, that won't affect domain or range. But what will be affected is the fact that we went up 1. We'll make our range be 1 to infinity. And our asymptote will be y equals 1. Our last example of this is going to be 1/2 of 4 to the x plus 2. Now, you might see 1/2 and go, oh, it's decay, but remember, it's actually 4 to the x plus 2. So, that said, the other thing you'll notice is we're going to be talking about x plus 2. That means it's moving left 2. So every x value is 2 over, and I still like to go pretty much from negative 2 to positive 2. But in order to get like that 0 that I want to start with, I can't have my x be 0 because 0 plus 2 is 2. I have to make it negative 2. So negative 2 plus 2 is 0. And 1 times 1/2 is 1/2. So at negative 2, it's 1/2. Now at negative 1, that becomes like the first power. So 4 to the first power is 4. Half of that is 2. So at negative 1, it's 2. At 0, 0 plus 2, that's 16. 0 plus 2, that's 2. 4 squared is 16. And half of 16, that gets us 8, which is going to be really high up, you can see. Now let's talk about negative 1. So negative 1 ends up being, negative 3 gets us that negative 1 we want, and that's 1 over 4, but half of 1 over 4 is 1 over 8. And half of 1 over 16, which would be our negative 2, or in this case actually negative 4, is 1 over 32. But now that we have all these points, we can graph. And let's talk about our domain. So even though we moved left or right, that's not going to change our domain. And then because we didn't move up or down, it's still approaching 0. So our range is still 0 to infinity. And our asymptote is y equals 0. All right, now we're going to talk about logarithmic graphs. A logarithmic function is the inverse of an exponential function. In other words, if you had a variable in the exponent and we're trying to solve for that variable, you may use a log function in the solving process. If this looks familiar, it's because we've already read these exact words, but it's still important to remember. In fact, it's so important that we're going to practice doing what amounts to almost the inverse before. Because when we're graphing, most of us don't know our logs, but if instead we solve using y instead of solving using x, we can sometimes still figure out values. So, for instance, log base 2 of x is now going to become 2 to the y equals x. That's the idea of what we're doing right now. So in this case, it would be the same thing, 3 to the y equals x, but we have this plus 2. So the first thing we have to do is we have to subtract 2. So y minus 2 equals log base 3 of x. Now, that means it's going to end up becoming 3 to the everything over on the other side, not just y, but 3 to the y minus 2 equals x. And now let's try this one. This one says y equals log base 4 of x plus 2 minus 3. So the first thing we have to do is get this minus 3 moved over. So that becomes y plus 3 equals log base 4 of x plus 2. Now, you might go, do we have to subtract 2 now? And the answer is no, not yet, because it's currently being, well, logged. So I'm going to first rewrite this as 4 to the y plus 3 equals x plus 2, which means our final version would be 4 to the y plus 3 minus 2 equals x. Now we're going to just describe some transformations. This will be a lot easier. I would start out with the plus 5 right here, and that plus 5, remember, ends up meaning the opposite direction. Sometimes we forget this, but it means left 5. And then minus 4, it is what you expect, so down 4. Right here, we have a 2, and notice this 2 is not inside the parentheses, so that means it's going to be vertical, and because it's greater than 1, it's a vertical stretch of 2. Then, right here, we have minus 7. But remember, inside the parentheses, it goes the opposite direction you expect, so that means right 7. All right, now we have negative log base 5 of x minus 1. So we have two major things that are happening here. First, the negative. That negative is a reflection on x axis, because it's going to reflect like this. Now let's talk about the next part. Minus 1 is down 1. Please do not think it's going to end up being right 1. It would only be right 1 if we had parentheses, which we don't. Alright, so now we're going to graph some logarithmic functions and state the domain and range. So the easiest way to remember this is to go, well, how would I rewrite this? And so I would go x equals 2 to the y. And if this looks familiar, it's because our first example was y equals 2 to the x, and it looked like, well, this. We had our points, negative 2, 1/4. We had negative 1 and 1/2, 0 and 1, 1 and 2, and 2 and 4. You might remember those points, and it ended up giving us this graph. Well, we also might remember the domain was negative infinity to infinity, the range was 0 to infinity, and our asymptote was y equals 0. But you might remember from what we were just reading that logarithmic functions are the inverse, which means we switch our x and y. So the log version of this will just look like this. Our domains and range switch, because domain is our x values, our ranges are our y values, and our asymptote goes from y equals to x equals. And this would be our new graph. All right, let's try this with one where we don't have it already written. Log based 4 of x minus 1. So the first thing I would do is I would rewrite this log based 4 of x minus 1 to become this. X equals 4 to the y plus 1. And I would just find x and y. So I'm going to start with 0, but now I'm doing it with y. Instead of saying 0 when it's x, I'm saying 0 when it's y. So at 0, x is 2. Because 4 to the 0 is 1, 1 plus 1 is 2. Then I'd go 1. 4 to the first power is 4 plus 1 is 5. So when y is 1, x is 5. It looks like we're kind of going a little bit too far if we keep going up. So then I'd go down, negative 1. That's 1/4 plus 1 is 1 1/4. And negative 2 becomes 1 1/16. And these are my new points. And you'll notice I didn't choose to just plug in x values, because I couldn't have figured out what it was when x was 3. But I could figure it out with these y's, and then I can just graph. So now let's talk about our domain and range. Domain, remember, is now what was the range. So we're talking about what is our furthest left we're going to go, and that's going to this time be 1 because we moved 1 to the right. So it's 1 to infinity. Whereas our range is going to be any number that we want. And our asymptote is now going to be x equals 1 instead of x equals 0. Now let's try this one. You'll notice this looks just like our first one that we had from this section of log base 2 of x plus, but now it's plus 3, which means we're just moving up 3, like this. Now, did this change our domain? No, because it didn't move left or right, meaning our domain is still going to be 0 to infinity. Our range and asymptotes also don't change. Let's try our next one here. Log base 3 of x plus 1 minus 2. So the first thing I would do in this case is rewrite it, which ends up being this. We first add 2. It becomes log base 3 of y plus, so it becomes 3 to the y plus 2, and that equals x plus 1, so we'd subtract 1, and we get this equation you see up in the upper right-hand corner. So let's just start plugging in some values. I start out, remember, because we're adding 2, I have to start out at negative 2 to get to 0. So negative 2 plus 2 is 0. 3 to the 0 is 1. Minus 1 is 0. Then I'm plugging in, let's see, negative 1 for my y. So negative 1 plus 2 is 1. 3 to the first power is 3. Minus 1 is 2. And then let's try it again with 0. So 0 plus 2 is 2. 3 squared is 9. Minus 1 is 8. I go down, negative 1. So in this case, it would be negative 3 plus 2 gets me negative 1. So 3 to the negative 1 is 1/3. Minus 1, this is where it gets a little tricky. 1/3 minus 1 is actually negative 2/3. Don't get that wrong. Don't say negative 1/3. It's an easy mistake to make. If you need to, draw a line where the asymptote is going to be. In this case, because it was moved left 1, it's going to be at x equals negative 1. And then you can kind of just graph it like you normally would. Negative 4 is going to be 8/9 because it would have been 1/9 whenever we actually plug that in. So then we can graph. And there we go. Now let's talk about our domain. Because we once again moved 1 to the left, it's now going to be negative 1 to infinity. Our range is going to be in negative infinity to infinity because that didn't change. And our asymptote is going to be x equals negative 1. And that's it. We're done. If you would please like and subscribe. Thank you for watching. I have other videos, including more about logs, right around here. Thank you. Bye.